Welcome, University Utara Malaysia computer science students. I'm Dr. Alaa Jabbar Almaliki, and today we're examining how to engineer systems that remain operational even after a zero-day breach. In late 2025, a major financial firm saw its trading algorithms freeze and customer data lock for ransom. Despite multi-million-dollar defenses, security monitors remained silent. The attack targeted an architectural logic error, a blind spot nobody knew existed. Malicious traffic bypassed every filter undetected. Defenses designed to identify known threats provide no protection against these unknown variables. In modern network engineering, relying on a database of past attacks is a mathematically losing strategy. The frequency of these attacks is increasing. A 2025 report from Google's Threat Intelligence Group tracked 90 zero-day vulnerabilities exploited in a single year. This timeline plots those 90 attacks against the performance of traditional antivirus software. Because these programs require a pre-existing digit signature to block code, they consistently return 0 matches while the breach is in progress. This data establishes our 2026 baseline. As engineers, you must design architectures that assume the perimeter has already been compromised by an invisible adversary. Target selection has undergone a significant shift. While attackers previously focused on user endpoints like browsers, While government hacking teams once held a monopoly on these tools, commercial surveillance vendors, for-profit companies that weaponize flaws for sale, now deploy more zero-day exploits than state agencies. High-end hacking tools are now commercialized products available on a global market. This drastically reduces the technical and financial barriers for launching devastating, large-scale attacks. Effective defense requires precise definitions. First is the zero-day vulnerability. This is a logic gate or memory handling error buried in the software's code, a specific execution path that the developers never intended and do not know exists. The zero-day exploit is the specific data packet crafted to trigger that error. It forces the system into that unintended state to execute malicious commands. The zero-day attack is the execution itself, occurring while the vendor has had 0 days to issue a fix. In the 5-stage lifecycle, the most dangerous period is stage 3, exploitation. This is the window of vulnerability, where the attacker is active within the network, but the developers remain unaware of the flaw. Once a breach is found and the flaw is disclosed, a second race begins. Attackers use automated scanners to find unpatched systems across the internet before administrators can apply the vendor's fix. Based on this lifecycle, at which specific stages is a traditional signature-based antivirus completely blind to the threat? Pause the video and evaluate the chart. Because no signature exists until disclosure, traditional defenses are blind during stages 1 through 3. This renders a purely reactive defense model obsolete. We must shift our defensive paradigm to an assume compromise model, implemented across 3 layers: individuals, businesses, and cybersecurity professionals. For individuals, immediate updates are the baseline. However, to stop credential theft, you must use phishing-resistant multi-factor authentication, such as physical hardware security keys, which are immune to interception. At the enterprise level, we replace the legacy castle and moat model with zero trust. By using microsegmentation, you treat the network like a ship with watertight bulkheads. If a zero-day compromises one segment, the breach is contained and cannot spread to critical servers. For professionals, the metric of success is no longer a theoretical CVSS-4. You must prioritize the CISA Known Exploited Vulnerabilities catalog. An active, real-world exploitation is always a higher priority than a theoretical flaw. Visibility now depends on behavioral detection. Endpoint detection and response tools look for anomalous actions, like a workstation accessing sensitive files at 3 a.m. Deploying decoy honeypots provides a high-fidelity alert. If a user touches one, an intruder is confirmed. As network engineers, you must prioritize the design of resilient systems that contain damage and automate recovery. Success is measured by how quickly a system can isolate a breach and keep essential services online. In 2026 and beyond, the conflict will be shaped by artificial intelligence. Offensive AI will scan source code for vulnerabilities at a massive scale. while defensive AI will be used to identify behavioral anomalies in network traffic in real time. Review this summary. Distinguish between the underlying vulnerability and the weaponized exploit. Maintain the assume compromise mindset, and utilize microsegmentation to ensure system resilience. True security means building architectures that can take a direct hit and continue to function. Your assignment this week is to select an active threat from the CISA KEV catalog. Post in the class forum with a network segmentation strategy designed to isolate that specific threat. We'll discuss your designs in the next lecture.